So let's work on this one a little bit. The first one, Chuck didn't have a question about this one, but still it's a good starting point. Let's suppose City Council want to curb emissions by half. Everybody reduces by half. Sounds fair, right? But this is the sort of the baseline case, and from here we see how we can make some improvements. Anyway, if they both have to clean up half, both move from process A to process C. That costs sludge $150. Their cost went up from $200 to $350. It costs Northwest Lumber $65. Their cost went from $50 to $115. And so we get a cleanup cost of $150 plus 65 equals 215. That wasn't where the questions were, but that's a good base case. I'm going to have a page each for B and C because I find I don't have room here. Let's think about this permit auction in Part B at a price of, let's just say, $1. That's it's a bargain, right? Both Sludge is going to want to buy all 4 permits, and Northwest is going to want to buy 4 permits, and there'll be 8 permits demanded, and there'll be no cleanup. So remember, we got to raise price until only 4 permits are demanded. So you can see as I raise it to 2, 3, 4, 5, 6, there'll still be 4 demanded by each firm. Total would be, of course, 8. Well, not until the price reaches 26, say, would we see a change. And sludge, it would cost it $50 to clean up the first ton of smoke. So at 26, sludge wouldn't be interested in reducing its quantity demanded. But at a price of 26, Northwest Lumber finds, hey, we can clean up 1 ton for 25, and that means we wouldn't have to buy that 4th permit. We'll just demand 3. And following that logic, price could go up, 27, 28, 29. No, there would still be 4 permits demanded by Sludge, 3 by Northwest, until price hit 41. And look at the cleanup costs on your tap sheet there. Now at a price of 41, Sludge, it would still want to buy 4 permits. But now Northwest is going to say, hey, I can clean up a 2nd ton for 40. I'm not going to pay 41 for a permit. So now Northwest's quantity demand is going to go down to 2. And then by that same logic, once the permit price hits 51, then we see Sludge says, oh, I can clean up 1 ton. That's cheaper than paying 51 for a permit. I'm only going to demand 3 permits. And then, of course, Northwest is their permit demand is going to be down to 1. And so now we hit it right. We have a price of $51 per permit. Sludge wants to buy 3 permits. That means it cleans up 1 ton. Northwest only wants to buy 1 permit. That means it has cleaned up 3 tons. So how much will each permit sell for? Permit price will be 51. That's part C. Part B. And then how many permits will each firm buy? Then we see Sludge buys 3 and Northwest buys just 1. Let's all have another page for just to take this home with cleanup costs. I think my next page will just have the original chart instead of repeating question for Part D, what'll be cleanup costs. But keep that in your head. That's what we're going to answer in the next slide. So Part D asks us cleanup costs. Under the tradable permits, or here the auctioned permits, tradability, just if a firm guesses wrong about how many they need, they can just adjust by buying or selling permits. But that's not something we're going to think about here. Well, remember that sludge bought 3 permits, so it cleaned up 1 ton. We see that sludge had to pay 50 to clean up, and the Northwest Lumber cleaned up 3 of its tons, so it went from emitting 4 to emitting just 1, and in doing so, it incurred cleanup costs of $115. And when we add these two together, we see that cleanup costs fell to 165, from 215 in the base case to 165, and that's a big saving. Turns out in the real world, the savings are even bigger. These some economists have estimated that if these incentive-based regulations, that these are regulations that cause the firms that can clean up cheaply to do so, and the ones that can't don't. Anyway, it's been estimated that if we exploited this possibility fully, we could cut cleanup costs to 1/22nd of what they are under command and control. So if they're $2,200 under the command and control, it's estimated that we could cut cleanup costs down to 100 and get the same amount of cleanup, which is really quite remarkable. A lot of that progress has been made since the move in the 90s to regulate regional pollutants by tradable permits. Of course, the carbon trading proposals to address the global warming issue, climate change issue, I guess I should say, are based on those are global pollutants, so it doesn't matter where you get the cleanup, as long as you get it. By having auction permits, you can allocate cleanup to the firms that can do so most easily and get that cleanup at the lowest cost. So there's a lot of promise to this type of regulatory system instead of the command and control that tends to be the historical norm, and still a lot of pollutants are regulated that way. I guess one more word. If we have a local pollutant, say the mercury that just drops out within a mile of the smokestack, that might be one you still want to, that probably is one that you still want to regulate via command and control, because we don't want to create these hot spots, these high concentrations of mercury near a plant that may buy a bunch of permits. That just, this system is probably not applicable to what we call local pollutants, but for regional and global pollutants, pretty good innovation on the part of regulators.
Made with Doodlecast Pro.